To find the area of steel, for using this formula, AST is 9157.86 mm square. Then check for minimum and maximum reinforcement. This calculated area of reinforcement is between the minimum and maximum reinforcement, hence provide 9157.86 mm square, and then calculate the number of bars. For using 40 mm dia bars, hence provide 8 number of 40 mm dia bars of main reinforcement. Total area of reinforcement provided 10,048 mm square. Here provided area AST is more than the calculated area, hence okay. Check for moment capacity of the section for provided reinforcement. Neutral axis depth of the section uh, equal to 140.09 mm. Lever arm Z equal to 1418.09 mm. Hence moment capacity of the section is 6195 kilonewton meter. Hence the moment resisting is more than, hence provide 8 number of 40 mm dia bars. Web reinforcement, side face reinforcement provide depth of the girder is more than 700 mm, hence 0.1% of the breadth of the web and depth of the web equal to 420 mm square. Diameter of the secondary reinforcement is 12 mm. Area of reinforcement is 113 mm square. Maximum spacing of distribution reinforcement 300 mm. Spacing of reinforcement provided 300 mm. Provide 4 numbers of each side, so hence 904 mm square. So AST provided is 904 mm square, hence okay. Provide 12 mm diode 300 mm web reinforcement on both sides. This is the reinforcement detailing of T-beam girder. Side face reinforcement 12 mm dia bar at 300 mm. Deck slab of 12 mm dia bar at 120 mm center to center. Top 4 numbers of 25 mm dia bars, and bottom tension reinforcement are 8 numbers of 40 mm dia bars, and stirrups are 12 mm stirrups. And design of inverter semicircular arch girder. The design data are: width of the flange BF is equal to 2500 mm, depth of the girder D equal to 1600 mm, and grade of the concrete FCK M35, grade of the reinforcement FE 500. Tensile strength of the concrete is 2.5 megapascal. Partial safety factor for concrete is 1.5. Reinforcement is 1.15. Design compressive strength of the concrete FCD is 15.6 megapascal, and design tensile strength of the reinforcement is 434.8 megapascal. And elastic modulus of steel 200 GPa, and second modulus of elasticity of concrete is 32 GPa. And maximum design bending moment is m equal to 3980.13 kilonewton meter. The same design procedure is followed for design of inverter semicircular arch girder. So finally the reinforcement detailing of inverter semicircular arch girder is: the main reinforcement of using 10 numbers of 40 mm dia bars. The overall depth of the girder is 700 mm, and effective depth is 570 mm, and depth of the deck slab is 200 mm, and the girder inner hollow section is 200 mm radius, and the outer radius is 500 mm. Here also provide side face reinforcement for 12 mm dia bars on both sides. Shear reinforcement is 12 mm dia bar at 230 mm center to center for 8-legged stirrups. Experimental analysis: dimension of T-beam girder. For experimental analysis, the size of the girder is reduced. For depth of the girder is 150 mm, breadth of the flange 250 mm, breadth of the web 50 mm, thickness of the flange 40 mm, depth of the web 110 mm, effective depth of the girder 135 mm. Here consider 1 meter span of the girder. Dimensions of arch beam: depth of the girder 100 mm, breadth of the flange 250 mm, breadth of the curved web 50 mm, depth of the web 60 mm, effective depth of the girder 85 mm. Design of beam specimens. For design of T-beam, the same about design procedure are followed for checking the sections and the area of steel. Here provide 4 numbers of 4 mm dia bars. This is the reinforcement detailing of T-beam specimen. The tension reinforcement 4 numbers of 4 mm dia bars, and tension top reinforcement 2 numbers of 4 mm dia bars, And slab reinforcement 4 mm dia bar at 8 mm center to center in both directions. And design of arch beam. They have design compressive strength of the concrete is 8.93 Newton per mm square, and design of tensile steel is FYD 217.34 Newton per mm square. Here used for mild steel. Here also using 4 mm dia bars for main reinforcement. Actual neutral axis. And calculate the moment resisting of the sections. Hence the section is resisting capacity is more. Hence the section is provided. Reinforcement detailing of arch beam system. 4 numbers 4 mm dia bars at 8 mm center to center for top flange, and 3 numbers of 6 mm dia bars provided at the tension zone or bottom of the girders, and top 4 numbers of 4 mm dia bars provided in top of the web. Preparation of test specimen. This is the reinforcement gauge for the before concreting of concrete specimen, and reinforcement placed into the mold for T-beam girder and also in semicircular arch girder. Load setup for test specimen. After casting and curing, 20 days curing, the specimens are completely dried and placed in 2-point loading. Die gauges was attached to the bottom of the flange at midspan, were used to measure deflection of all beam specimen. Loading and deflection measurements were recorded at each load stage. The crack pattern were also observed. Results and discussions. The testing is carried out for 2 number of beams, in which one is the T-beam and other one is the inverted semicircular arch beam. Various comparisons are made in this test with the T-beam, and the major parameter compared are strength, deflection and various cracks patterns of the beam. Results of various stages of loading, discussion of flexural behavior, load displacement curve, crack pattern. The flexural behavior of these two girders. The T-beam girder is initial cracking is 36.8 kN and ultimate load is 69.5 kN, and inverted semicircular arch beam is 50.2 kN for initial cracking, and final failure for ultimate load is 82.6 kN. Hence the maximum load carrying capacity is increased for the web of the beam is curved in shape, and load deflection curve. And load deflection curve for T-beam girder based on the load and deflections. This is the load deflection curve for arch beam, and cracking pattern and failure mode. The crack shapes are marked in the round circle in T-beam girder and also arch beam girder. Conclusions. Inverted semicircular arch girder showed as a significant increase in the load carrying capacity than the conventional T-beam. Inverted semicircular arch girder showed an increase in ultimate deflection than the conventional T-beam. For inverted semicircular arch girder, reducing the self-weight of girder up to 20 kN for each girder, hence overall self-weight of the superstructure is reduced. Construction cost of inverted semicircular arch girder is minimum in compared to the T-beam girder bridge. Thank you.